So welcome everyone. My name is Ihor Dvoretsky. I am a developer advocate at Cloud Native Computing Foundation. And I'm together today with Caitlin Bernard, who is integrated marketing specialist at Cloud Native Computing Foundation, who will help us with the webinar driver. And today we'll speak about the best practices of using jsonnet and kubecfg to manage Kubernetes environments as a code. Our presenter today is Juanjo Chirolante, Senior SRE at Bitnami, and also he's a certified Kubernetes administrator. So Juanjo, if you are ready to start, go ahead, please.
Thank you very much, Ihor. Thanks everyone for joining indeed. Hope you can hear me well. I hope Ihor will be taking care of your questions, so please do so if you have any doubts. I'm speaking from Mendoza. Yeah,
just one note about the Q&A section. I'm sorry for interrupting. So we will hold around 10 or 15 minutes at the end of the webinar to cover your Q&A, to cover your questions at the end. Yeah, I'm sorry for interrupting. Please go ahead.
Thank you, indeed. So I'm speaking from Mendoza, Argentina, near the Andes, the beautiful Andes Mountains. Autumn is starting to pop up here, so it's pretty cool. So we'll be talking about creating our Kubernetes manifest using JSONnet and applying them live with kubecfg CLI. These are the main topics for today. And indeed, working as senior SRE for Bitnami, that's the main motivation behind this talk, to share with you folks what all the goodness to say that these tools have brought us in our day-to-day DevOps workflows. A few words about Bitnami. If you don't know us, we package application for all the major cloud providers, that is AWS, Google, Azure. We talk about 150 open source applications. We build, package, and publish them into their marketplaces. We also build standalone VM images, Docker containers, and so on. And we have contributed with many production-ready Helm charts and keep doing so. Also, we recently launched an enterprise-ready solution called StackMeet. We captured our knowledge and best practices on packaging application to help companies with moving workloads to the cloud. Regarding Kubernetes itself, we have many projects in the Kubernetes ecosystem. KubeApps essentially is an in-cluster application that you can deploy. It includes Helm chart dashboards that you can use to browse and deploy your charts in your cluster. Kubeless, our Kubernetes native serverless platform. Helm charts, indeed, as I mentioned. kubecfg, that will be the main focus, one of the main focus of this talk. And then Seal Secrets. This is actually a pretty cool project where you can use public crypto to handle your secrets in the clear. That indeed means having your secrets, for example, committed into your own source code repos. So more or less the agenda. So we will try to frame the scope of the talk, and then essentially the talk will be kind of couple parts. One will be talking about JSONnet itself, the language applied to Kubernetes manifest, and then how we can use kubecfg to take advantage of it. So for Kubernetes, I guess that you already know YAML manifest. You may have used Helm in the past to try to use a more templated way to deploy them. So we know that YAML manifests are naturally declarative by design. This is the whole design behind Kubernetes under its controllers. And indeed, we typically use them to describe our workloads. Usually we talk about this as infrastructure as code, but actually there is a link there in the slides that you will have there. This infrastructural software from the point of view that you upload what you want to be the state of the world, what you want to express in your manifest. And then the Kubernetes controller will take care of the actual workloads respecting or following that manifest. But then the question comes on writing the manifest themselves. And that's the place where infrastructure as code has its place. How For example, I'm sure that you have faced the situation where you have the same application deployed in different environments, typically staging and production, and there are a few differences between these two, just a few. And then the key there, the question is how you handle this difference. Do you have a common template that you replace by some shell scripting? Do you actually use some language to try to templatize them? So the focus of this talk will be talking about one of these options, doing this using JSONet. Um, uh, by the way, also in this scope of application deployment projects, there are kind of 60-something entries. Garrett R, I don't recall his surname, has a very cool spreadsheet there with indeed more 60-something entries there. More or less the players in this space are indeed Helm, K-Compose, that is more oriented to people coming from the Docker world. Heptio's jsonnet, this actually was a project together with Bitnami. What we will be talking today, Bitnami's kubecfg using JSONet. By the way, indeed, if you see JSONet and kubecfg, they have a common root. Essentially, this was the same project up to September past year. And then they diverged a bit regarding the approach on how to describe your manifest. We will mention something about this in the next slides. So, sorry for that tab. This seems to be something regarding my full screen. That replicas thing should be there on the left. So just to mention, this is kind of a common YAML manifest where you see there kind deployment with fields like, for example, metadata labels. And so one thing to keep in mind here that you see a lot of repetition, and this is kind of a common pattern when you describe your manifest. You will see that you are repeating, for example, you want to name the actual deployment some way, my nginx in this case, but you also want to create a label that has that is up with the same value, and also you want the pods to have the same label, and also, of course, the deployment needs to know about the labels of the pods to be able to control them, and so it needs to have the match labels to match the labels here. So there is kind of a lot of, if you think this from a point of view of templating it or trying to come up with variables, you see a lot of repetition that will be achievable by some kind of more powerful language than YAML. By the way, just to mention, YAML does have aliases. I have used them in the past. If you see the YAML specification, you can actually create some kind of variables that are called aliases there, but they just stop there. You can alias against a string or maybe a piece of structure, but there is not much more that you can do. So keeping in mind this, I'm going to switch into Helm. I don't know how much keen are you on Helm, but just to do a brief introduction, Helm is what is called the package manager for Kubernetes. Essentially, the approach of Helm is having an in-cluster deployment that is called Tiller that will handle you will talk to Tiller to be able to deploy your workloads, and indeed has a way to templatize all these manifests, deployments, config maps, and whatnot, in a way like this. I'm going to switch between the two screens just to highlight how a Helm template takes what's the approach from then. As you can see, it has replaced all these kind of fixed values that we have in the YAML by something that is written in Go template. You can see the braces there, these couple braces. This is Go template lingo. And indeed, the approach taken by Helm is to have a common template that will have all these replaceable values expressed on the root of these common templates. I'm mentioning this because this is exactly the opposite take of JSONet from the point of view that in Helm, your template needs to know about everything that must be replaceable For example, down there, you can see the container port. In the context of Nginx, that's obvious. But let's say the application will have the port configurable in the Nginx. That's have it via a command line argument. If you wanted a port to be different than 80, then you will need, in the common template, you will need to actually create the space for this variable with this templated annotation, so that later when you materialize this deployment, you will be able to override the default value. And this is the main difference in JSONet. In JSONet, as we will see, you start with an opinionated, very small original template, and you have the capability to override these values at rendering time, to say. In the next slide, we will stop here for a moment to describe what we see. By the way, just a question, Ihor, do you see my mouse pointer?
Yes, we can see it.
Ah, awesome, cool, thank you. Because if I click, it will switch to the next slide, so I wanted to be sure.
Yeah, no, that's not a problem. Yeah, we can see it.
Awesome, thank you. So here you can see this will be more or less the equivalent of what we've seen in the previous slide. Recall what we saw the plain YAML, we saw the templated approach by Helm. Here we see kind of a very different beast. On the right, you see something that's called kubedeployment.libsonnet that pretends to tackle what would be common fields in a Kubernetes deployment. As you can see, there is nothing specific here to Nginx, but kind of places where we can override this. Just a bit of JSONet here. So essentially, JSONet, you can think of a JSON that can be programmable, to say. You can see several differences here. The one that spots at first is that the left side of the column does not need to be a quoted string. Essentially, as you can see, for example, API version is not quoted, kind is not quoted. If this was a JSON, this would have to be quoted. And then you can certainly see these dollar things. Just keep in mind that these braces are, let's say, natural JSON braces. They're not strictly part of the layout of the language. How this works. So essentially, you can see I created here Nginx-based JSONet that imports from this deployment, and then it overrides some values here like name and container. This name and container here, they are replaced. They actually, these are values for these fields that you can see: name double column, container double column, so that when at render time, they will have the value that is specified here. How you fill up the actual template with this, you can see, for example, $.name. This is not a typo, it's not $name, it's $.name, because dollar refers to the root of the object, like where I have the mouse here. So $.name will be indeed the field that is from the root called name and so called container. You can also see some interesting construction here. JSONet has what is called the lazy evaluation, like late evaluation. And you can see here that even defining containers here that will be the list of containers that we want to deploy, we can do a late override by the name provided by the actual file that is importing this. So all this resolution of these variables will happen late after this is imported and then lazily resolved. Here are some annotated things. So $name points there, and then you can see in different colors, like for example, light blue, you can see $.metadata.labels pointing to metadata labels here, and so. As we talked when we saw the original YAML template, that we're repeating a lot of fields there, you can see how JSONet tackles this. By the way, I didn't mention, but JSONet is not really is agnostic regarding the scope of what you want to use the language for. It's not that it's meant to be used for Kubernetes. It just happens that you can express your manifest in JSON for Kubernetes. But for example, in Bitnami, we use JSonnet, for example, to build Grafana dashboards, to build Prometheus configuration. That obviously their lingo, their structure, the schema is not a Kubernetes schema. It's something that is application specific. But we use all these features of being able to create a template and then do a late replacement and evaluation of the fields. You can see here, this will be, when we do the demo in the last part of the talk, I will show this again, but essentially taking, going back. So I will take this nginx base.jsonnet that imports the kube deployment libs JSONet from here. And then you can see the output from a couple of tools. There is indeed a JSonnet CLI that will essentially evaluate your JSonnet. And you see the output of this is JSON. So indeed, JSonnet can only output JSON or maybe stream of YAML with pieces of JSON inside, but cannot output YAML. We will see that kubecfg, the CLI that we will be talking today, indeed by default does output YAML, and this YAML output is mostly equal, if not completely equal, to the template we originally saw there. Following up on this, you can see how this works. Of course, we can do multiple imports. By the way, I didn't change at the right. I didn't change the kube deployment.libsonnet there. It's the same that we are carrying since a couple of slides before. We see that nginx base imports from kube deployment here, and defines some opinionated values for what would be my nginx base deployment. It will be, I put there a name, but a container, I use a specific image because it's the image that I'm working with at this very moment. And then you can see, again, by creating another file, you can import from here, and you can override things like, for example, the name indeed, this will be my nginx instead of being nginx base, and then I will overload with replicas equals to. As you can see, we'll stop here for a moment. If you search replicas anywhere else in the screen, you won't find them. And this is pretty cool because, and that's the whole point behind not needing to inflate your original manifest. So this templated manifest, you can express whatever opinions there you have. We will see this in deployments. You can express things like, for example, max surge or max unavailable pods when you do a deployment update. And you can certainly opinionate this, but you are free from overloading this later while doing the evaluation. You see indeed that replicas was not present originally. Of course, I need to know the schema of what I'm working with. In this particular case, I do know that this is a Kubernetes deployment, that replicas goes in the spec file. By the way, there is something subtle here. You can see spec plus colon. This is a language construct indeed. If I didn't put that plus here, essentially, you can imagine what will happen. Spec will become just replicas equal to, completely ignoring what I'm carrying from the spec on the right. So this spec plus is a language construct that smells kind of object oriented. Essentially, I'm kind of deriving this from the base spec, and I'm overloading it with this particular field, with this particular value. Doing the same as we did some slides before, if we do the JSonnet or kubecfg show, of course, you can see the new fields here. And in particular, you see, by the way, these are actual screen captures that are pasted here. You can see that everywhere the my nginx name is present, like in the name of the deployment itself, but also all the labels all the way down. And also, of course, the replicas overloading. And the same in the YAML output provided by kubecfg show. I'm going back just to show the difference, just to recall this was the original one that where you can see nginx base everywhere there with no replicas. And then now we have this overloaded by this. Now that we have seen a bit of JSONet, we're just to kind of better describe it. Indeed, JSON is a language created by Google as a kind of JSON-like programming language. It's modular, it's deterministic, for example, and indeed it's a very it's indeed oriented to create JSON outputs. For example, there is no printf to say. It's declarative. There is no being deterministic also. You cannot say, for example, create a random value. So it's indeed by design done in a way such as provided with the same inputs, it will always give the same output. It has its own stdlib standard library. It's pretty powerful. When you start working with more advanced JSONet, you will see that you will need things like, for example, give me all the keys of, for example, I want all the values here. Here you may have not metadata or maybe labels here. Give me all the fields, the keys for all the labels, and then you will have the labels name or maybe all the values because you want to derive something from that. So these kind of things that you have in the standard library are pretty powerful. And as we mentioned, it's not restricted to any particular use. Anything that can eat JSON can be expressed in JSON. And I will mention a couple CLIs here. JSONet CLI, that is pure JSONet CLI. So you provide it with a single JSON file and will indeed do the rendering and give you a JSON output. Does not do any schema validation at the moment. Compared with kubecfg CLI, you can think of kubecfg CLI as a JSONet inflated with Kubernetes knowledge, schema knowledge, and being able to talk to the API. Or maybe you can put the other way. It's kind of kubectl-ish, but augmented with JSONet capabilities. So essentially, indeed, it parses JSON files and to YAML or JSON to construct Kubernetes manifest. It's written in Go, and you can get it from there. By the way, all these tools, of course, are as you can see there, are the links are all open source, and you can download them, or maybe even a binary build. Now going more into the scope of this talk. Usually you will, we've seen so far, essentially we were playing with 3 files. We created something that is called kube deployment.libsonnet. That was an agnostic deployment with no particular things. Then we have nginx base, and then we did my nginx. But usually there is a point where you have this kind of these levels of interaction of templating. We have a common template. You define your service. In this case, would be nginx base, for example. And then here you want to differentiate between staging and production. And I highlighted here some interesting things. As we talked before, these are the same replicas overloading. But as you can see, you are free here in the final rendering to overload whatever you want. For example, on the right for nginx production, you actually may want to be more strict regarding the rolling update strategy to provide, say, something like max unavailable 10%, so that when you do a rolling update, when you do something like kubectl apply, or as we will see, something like kubecfg update, you only allow 10% of your pods to be unavailable. You allow that percentage of surge, that is of extra pods during deployment. You are making you put different number of replicas for staging and production. And again, I want to highlight here this construct. See how we augment metadata by the namespace. And in this case, this is pretty powerful from the point of view that allows you much freedom regarding how you want to tackle, in this particular case, staging versus production. Depending on how you work, for example, you may want to have, in this case, we are selecting different namespace. We are doing app staging, app production, as our different namespace with the same name, but you may want to do actually the opposite. You may want to use, or you may be forced to use the same namespace, and you may need to use a different name for production versus staging. And essentially, this is just a way how you will write these final JSON files. Here, a quick kind of trying to compare now talking about the kubecfg kubecfg CLI. kubecfg does not replace kubectl. It's not meant to be so, but indeed it provides some cool features that we will see during the demo. Essentially, they are more or less the verbs that we will see. Just to put us in context, kubecfg update, and then you provide the file, is more or less equivalent to kubectl apply. And actually, it will create the resource. It will fetch the resource, apply the patch if it's already existing to update the resource you're referring to. One very interesting thing here is that in kubecfg can also operate on JSONet, but also on YAMLs. So even if you don't switch or maybe until you move your manifest to JSONet, you can still use kubecfg power to do things like update, like showing the diff against running deployment. Delete, this is more or less equivalent. And then things like validate. This is pretty powerful for example, when you build CI's pipelines. The fact, for example, to be able to do a validation before going for an update, so that let's say that you have a Jenkins pipeline to deploy your workloads, and then in one of the stages of your pipeline, you do a kubecfg validate, and then of course stop if it doesn't pass the validation. I wonder if there are any doubts about JSONet. I guess that there may be many, but something that is blocking you folks from more or less grasping the scope of JSONet. Just before we move to the more demo moment with kubecfg. Okay, I will assume no. Okay, cool. So essentially, I have here more or less the same files that I described there in the slides. You can see here. By the way, it's nice to Vim already has JSONet syntax highlighted, so that's awesome, pretty awesome. So let's see how it looks. So indeed, I will essentially more or less, at least on the start of the demo, repeat what we saw during the slides. Let's see how this works. By the way, this will fail. Indeed, and I want to stop here for a moment. So as you can see, this will fail indeed. This is more or less the same as trying to instantiate a class with a virtual component. So you actually need to implement something because you cannot move forward. And this is written here in this libsonnet template. Indeed, there is an error. This is part of the language, and indeed it will stop if it does not have a value. Here doesn't have a value, as you can see, it's referring to a value, but it's not providing that value, nor name, neither container. Another thing I didn't mention, but it's pretty important, you can see, switch yourself to reading a Kubernetes manifest. We do know that these fields are this manifest API version, but this is not. So there is no name or container field at the root of a Kubernetes manifest. So JSONet provides this very, very convenient way of describing this double column. This double column is a place, indeed is a field that can be evaluated on like lazy evaluated, provided a value, but will not appear in the output. So that, for example, this is more or less equivalent of what would be arguments to this class. Is not exactly that, because you can also build functions. We have many of them with JSONet, but it behaves like if these were the main arguments for this function that is not for this class, I would say. If you see how this works, if you see Nginx base, you will see that indeed does satisfy the fact of providing a name and providing a container was what the base class to say was requiring, so that indeed, as this guy previously failed, this guy will not. This guy would actually provide an output, hopefully a valid output. By the way, I said hopefully because we are using JSON here. This is agnostic. You can write whatever you like here. We are just in the scope of Kubernetes manifest. Let's see how it looks when we do kubecfg show. You will see that you see indeed that by default it does YAML, so it's much more friendly to our human eyes, YAML. Another thing that we can do here is kubecfg validate. This will indeed talk to a Kubernetes API endpoint, and indeed it does require a valid live Kubernetes API endpoint, because it will fetch the schema and validate that all the fields that I have there are indeed valid. You can see it went well. This is the kind of thing I was mentioning regarding building your CI pipelines. If we go further, recall that we have Nginx production JSONet that imports Nginx base and overrides some fields. In the same way, of course, you can do, sorry, you can show, and yeah, you can validate, if I type correctly. One interesting thing that we use when we deploy our CIs is being able to assess the final rendering differences. Because the thing is that I'm going to introduce here another example. It will be easy to follow. This is an example that actually brings in. Let me do a comparison here. By the way, this is VI. Cool. So the difference here, this is Nginx production v2. The difference here is that we already have the deploy, but now we include another thing, a config that inherits from kubecfg that is a variable that has been filled up with the kubeconfig map libsonnet. As you can guess, kubeconfig map libsonnet is essentially the same tag that we did with kube-deployment.libsonnet in trying to come up with a simple, a very simple but valid template for the config map, for Kubernetes config map. Here you can see something interesting is the fact that this is quite a different object here. You can see on the left, this is the one where we were playing with in the slides. This is essentially a single object, a single map, a single if you want dictionary, that will be indeed a deployment with this name and blah, with all the substitutions. This is quite different because this is a map, a dictionary with several keys here. You can see the keys deployed. I could have chosen any key, but the thing, this construct, as you can see, this deploy field has a value that is the nginx deploy coming from nginx base that then I override with what I want there. The new things that I have here, if you have played before with volume mounts, you know that you can, for config maps, you can mount it as volume that will appear as a directory with each of the config map keys being a file there. And this is what we are doing here. In this particular case, below we have a config map. We will take a look in a few. But here the difference is that we are doing this volume mount. We are calling it with something that we can refer to later, and we are mounting it exactly on the path where this service, in particular nginx, expects the index, their assets to be. And then we are referring here from inside the container. Again, recall that in the original, in all the previous JSonnet, there was no mention of any volume mounts. We are building it late on the evaluation pipeline. That again, for me, that's kind of mind blowing. Some goodies from here. For example, here we manually made this volume mount name to match the volumes. This is required for Kubernetes to actually know that these are the volumes spec for the pod, and we want this container to mount this particular volume. But for example, here, as you can see, config map is using again a JSonnet construct to go there and refer to it by its replacement. You see here that you have the config map that has this particular name that is config.name. This will be obviously replaced on rendering time when it's finalized. Another pretty cool feature of JSonnet, you can not only import JSonnet or JSON, by the way. For example, you can even have original Kubernetes manifest written in JSON, and you will be able to do something like import plainly here, like import that JSON that describes the standard Kubernetes manifest, and import it here into this namespace, to say, into this object, and then be able there to override any field and with any value you may need. In this particular case, this is different. This is import string, and you can see how this works. I'm creating here in this config map, I'm populating its data with an index.html key that will be, which value will come from this particular file. And this particular file, as you can guess, is just some kind of full simple index.html. The key take from this is how this differs, how the thing on the right differs from the thing on the left. The thing on the right, we have several different, this guy and this guy. We have different contained objects here, or maps. By the way, I have here the same construct, like namespace and defaulting to app production, because indeed this is the production deployment. But this, if I have even another file that derives from it that includes it, you will be able to also override it. Cool. Let me show you. We'll do a bit of, it's not that black magic. So what I'm trying to get here is what I mentioned regarding being able to see the differences between the two. Of course, you usually have this in a proper source control, like Git, for example. this is really bad practice, like Nginx production and Nginx production v2. It's just for the sake of clarity here and being able to have them both to be able to show it. But usually you do things like, for example, showing the previous commit of the JSONet, grabbing it, and then passing it to kubecfg to show the output. I will show you here the difference between the rendering of these two. As you can see here, you can see that we created a completely new object. Indeed, the config map Kubernetes has this index. I have not shown the content, but you can see it. You can see it here. This content came from import string indeed, and you can see also the added volume mounts and volumes referring to the config map. We can try deploying this. Let's validate it before. Sorry, kubecfg, validate. By the way, I didn't mention, but show is does not talk to the Kubernetes APIs. It's essentially just behaves like mostly like local JSONet. So let's try to see how this works. As we showed, update is essentially the equivalent to kubectl apply, more or less. And then you can see that indeed is applying this. The output here is showing the namespace and the name, so we can do something like kubectl get post namespace production. There we have them running. I could even do something like you know, do a kubectl proxy and port forward, and then try to hit one of the Nginx, and we will see the index HTML there. But I won't spend time on that because we have more interesting things to talk about. Let's say that we want to actually handle both here. Let's say that I want to indeed, in a single invocation, we want to update both. Recall that kubectl, you can pass only a single file. And we will see there is a very strong reason on the fact of being able to use, to pass several files, JSON files to kubecfg. In this case, we will do the same. As you can imagine here, we will have the Nginx deployed to up staging. And you can see the difference here. Like it says updating and then repeats updating this. And here is actually creating the non-existent deployment. Another very interesting feature is that you have diff. By the way, I will take the liberty to do this construct. This is just shell foo, and buffer comes from the expect package, just to provide a TTY to kubecfg to provide me color, and less-r indeed to show me color. Else, this will be pretty flat without colors if I pipe it to naked less. This is the difference. Recall where we at. We did kubecfg update, and then immediately we did kubecfg diff on the things we deployed. By default, kubecfg will show you the diffs, and then you can see that this thing has been indeed annotated by Kubernetes itself, by the API endpoint. Sorry, the controller would be in this case. It did some annotations to, for example, uniquely identify this particular deployment, so that if you do a save and you save the state and then you do an apply, you can refer to the same. And this is actually, I would say, pretty noisy. These are, from a point of view, kind of runtime values that were defaulted by Kubernetes, were not strictly defined by you. And like these values, for example, they come from the intrinsic Kubernetes defaults. So kubecfg diff does have something that is diff strategy subset. And this will be the difference that we will show you will be a subset where this subset comes from what you define there in your manifest. So if we do so, I'm just going to clean this because it will be a very short output. You can see that they are unchanged. So we are getting rid of these extra fields and only considering the fields that we have here. One very cool feature of kubecfg is that it has something that is called garbage collect tag. So let's stop, sorry, tag. Let's stop here for a moment. Usually when you have your set of manifests, it's very hard to get rid of what was deleted from your manifest. So how you describe the nullification of one manifest? Do you put a null manifest there? That will be actually an invalid object for Kubernetes. So kubecfg provides this gctag feature that will actually annotate the deployment with whatever value you put here. Let's say, for example, that we call this whole deployment nginx all, where nginx all is this particular tag to describe the universe of nginx that I want to deploy here. In this particular case, I'm not going to delete resources because Kubernetes, kubecfg will be able to see that they are live and will actually apply the tag on top. So essentially, this is kind of indeed tagging, indeed marking all these resources with this particular tag. So that, let's say, if I wanted to get rid of the staging deployment, indeed, because this tag covers the whole universe of this particular stack, usually in this case, you will call that not nginx all, but something like the whole application stack that will be service, not service from the point of view of a Kubernetes, but kind of service foo, being service foo, whatever set of all resources in Kubernetes you need to describe your whole service. And indeed, you will pass all the JSONets. That could even be a single JSONet that imports from them all and then does a composition of all the other objects, or maybe there are different files. But here, because we already tagged this, by the way, I would like to show how that tag looks like. What I'm going to, here I'm going to take with kubectl, I'm going to get the deployment in that namespace. I know that this is its name. Output in JSON, I'm going to grab just metadata. And then as you can see, there is this new annotation here, this particular annotation that has the value that I put there in the GC tag. So such as, if I do this, you will guess what happened. What will happen? In this, it garbage collected what was previously tagged with the same value. By the way, some important note regarding this feature, as you can see, it actually went there. Take a moment to think about this. kubecfg update with this tag nginx production v2. We know that nginx production v2 in this particular case goes against this namespace, but there is no information here for kubecfg to know about the other namespaces. So it's important to mention that this is kind of pretty expensive operation somehow, because it will need to fetch from all namespaces all the objects that have this particular annotation. So also all the RBAC, I mean all the rules, all the permissions RBAC will apply here. So you obviously need to have access to all these other namespaces to do this garbage collecting. And just to do a cool thing, non.jsonnet, that's essentially a nil JSONet. So you can guess if I do this kind of to show your friends, I do not delete Kubernetes resources. I specify a GC tag with a nil value to get rid of all what I had tagged before.
Apologies for interrupting, but we have only 10 minutes before the end, so.
Thank you. Yeah, this is essentially wrapping up. So just to show you, you can see that it garbage collected also this, because essentially what I told it here is get rid of anything that has this particular tag, because non-JSONet in this is a nil spec. Cool. So I wonder if there is any questions?
Yeah, we have one question in our chat. So will Helm chart YAML deployment method change if we use kubecfg instead?
I know that there is some project trying to bring these two together, but that wouldn't be the scope. Let me think for a bit, because essentially there, Tiller is in the middle between the Helm CLI and Tiller to do this. It's actually a pretty cool question. Nothing will actually prevent the internals of Helm to use JSON to describe the templates. Yeah, indeed. I wonder, the thing is that the whole tackle of Helm, how you override the values by passing the values in an artwork command line, or creating your values.yaml to prefill them, interacts there. So I think that it would be possible to do an implementation as such, but it will be kind of a mismatch. I think this is mostly my opinion regarding the take of JSON on this. By the way, something I didn't mention here. I really don't want to rant anything about Helm. We actively contribute to Helm charts, and so we didn't choose Helm to do our deployments because Helm is not secure in a multi-tenant environment. You will see there in the slides, I left there a pointer to a very good article by a colleague of us, Angus Lee, actually works for Dynami also, which is very clearly describe the security issues. Essentially, Tiller there is kind of the full admin of the cluster, and anyone can talk to Tiller in the file configuration and can do anything, even become cluster admin yourself. And this was one of the reasons of indeed not using Helm. We are not, for this very reason, we are not using Helm in any of our production classes. Yeah, just wanted to plug that. Just to mention that at least Helm v2, the current instantiation of Helm, there is effort on Helm v3 to actually fix this and come up with different schemas, like instead of directly talking from the Helm CLI to the Tiller to the Tiller pod, actually do something via CRD, that is custom resource definition in Kubernetes. But this is a much work in progress.
Perfect. So another question is, if your RBAC role allows you to read some namespaces, but not to update scenes there, how would kubectl GC take behave? Would it give an informative error?
I would actually need to look at the code. My take, also knowing Gus, the author, it will be that it will actually fail. There are some command lines that recently have been added to do a kind of soft thing, but it's like soft failure. But were not in these were not in this scope. My guess, if I had to actually implement it, it will indeed, you will be able to list the resources there, but because the RBAC does not allow you to delete, it will fail, and it would be cool for it to fail because you are being imperative on the fact that you want to get rid of the resources, and indeed you want to fail, especially if, let's say, if you're implementing this in a CI, you want to get rid of that you, for some reason, you want to get rid of. But I'm talking from what would be a kind of a reasonable design of it. I don't know the answer, but we can look at the code.
Sounds good. So we have extra 2 questions, and I hope that we can finish with that because we have only 5 minutes. So is GC tagging actually removing deployments? What's the scope of GC here?
What's the scope of GC? So essentially, because this is a Kubernetes deployment. Sorry. Indeed, let's take this one in particular. Recall that this guy had 2 Kubernetes resources. One is a deployment and one is a config map. Recall that these are provided by this kind of mini library that we created here. When I did the gc tag, recall that I applied this command against this guy, this gc tag. It overloads, so it indeed talk with the API and overload here as if I had put here something like annotations called with this particular key, this particular value. So it modified every single Kubernetes resources here and annotated with this GC tag. So this allows me, for example, I'm not going to do it because of time, but let's say that later we decided to change this to a secret or something, so I get rid of this config and I redo that very command. Indeed, because the previous resource was already GC tag, will be actually removed here because these manifests are not express that resource. So indeed, the scope will be the scope of all the Kubernetes objects that are present in your JSONnet or YAML or JSON manifest. This is the scope. These are all the resources that get tagged in the first place.
Perfect. So the final question is, which pieces should be committed? On a libsonnet base and jsonnet, or the generated YAMLs as well should be committed to source repo?
That's a very, very good question. Indeed, we had that discussion internally at Vietnam. We currently are committing both because we lack one piece of CI integration to do something like so. The thing is that in a perfect world, you will not need to commit the generated outputs. You will just commit the source, but that will be in the case that where you have your CI protecting you from making mistake. What I mean by this, I mean like something like, for example, let's say that you have a CI step that we actually do the equivalent of this. Recall what I did here, this diff between production and production v2 to show you something like this. Sorry, I'm going to save this. So this is the key thing, the feedback of this difference. Because the thing is that when you start learning about JSONnet and you become more empowered on JSONnet, you try to you know, as we all programmers try to do, you try to create more common structures. You have to create functions. You try to create more code to describe your manifest. And then the thing is how you assess that the output has not changed. That's the key question. If you have a CI that will show you what I have here on the screen, and then we'll say wait for a human or something to actually validate. Okay, yeah, this is what I really wanted. Or maybe you have some scripts there that will do something like, imagine a git show previous commit, feed it into kubecfg and do the equivalent of the command line that I have here, diff between the previous and the current one, so that the reviewer of my code will say, okay, sure, yeah, this is what is needed to be changed here. But if you don't have such, you may want to actually commit the generator so that in a review from your peers, you will actually see the difference in whatever you have to do the reviews, like for example, a PR in GitHub, something like that. And you will be able to assess, okay, yeah, I do understand the final YAML difference. I do understand that this is what I want to do. That will be more or less a decision there. There's just to mention that indeed we are with the latter, because we don't have this particular CI integration completed. We indeed are committing the generator so that when we review other guys' code, we are able to do this assessment on the final output.
Right, perfect. Unfortunately, we ran out of time, but thank you for presenting this amazing topic today. Thank you for all the participants who joined us today. I'd like to remind you that this webinar is being recorded and it will be available really shortly on the cncf.io website. Also, I'd like to remind you that we are running the Cloud Native webinars every next week, so I hope to see you on our next webinar next week. Thank you and goodbye.
Thank you, guys. See you.